So in this problem, we're asked to consider a parent function, f of x equals 2 to the x power. And you can see I've written the parent function here in black. And then say we've got this transformed function shown in red. What's the equation of the transformed function? And all we're given is the picture, which shows a line that's exponential of some kind. And it also shows this point right here at x equals 0, y equals 1 on the original parent function. And then that point seems to have moved down and to the left in the transformed function. So when we're thinking about what's the transformed equation, or g of x, we should think about the kinds of transformations that have happened in this picture. And remember the kinds of transformations we can choose from. There are shifts, there are stretches, and sometimes those are also shrinks, right, if you compress a function. So you can stretch or shrink, you can shift, and you can also reflect, or in other words, make a mirror image of some kind. And as I'm looking at this, I see that, well, this is obvious. The function seems to be going to the left and down. Okay, so I have a pretty good idea that there are going to be shifts involved. But there's also a change in the orientation of this curve. Instead of being flat on the left and going up on the right, now it's flat on the right and it's going up on the left. So what has happened here is that the whole thing has spun around the y-axis. And if you remember what kind of a reflection flips something around the y-axis, that is a horizontal reflection. So we're going to call this a horizontal reflection across the y-axis. And the reason I want to emphasize that it is a horizontal reflection is because that reminds us that whatever this reflection is, this negative sign, it's happening inside the parentheses. Okay, so that means the x right here is actually turning into a negative x because it's a horizontal reflection, as opposed to a vertical reflection, which would be a negative sign outside the parentheses. That's not what's happening here. We're doing this inside the parentheses because it's horizontal. So go in order. We've got a horizontal reflection here. We've got some shifts, and it's not clear yet whether we have any stretches or shrinks going on. But what you can try to do to figure that out is do some basic counting, right? On this one, let's see, I've got this point here, and if I go, where's my pen? There we go. If I go over 1, up 1, I have the next point on the curve. Well, take a look at this red point over here. If I go over 1 to the left and up 1, yeah, it looks like about that point on the curve. So it doesn't seem like the curve has been stretched in any way. That 1-to-1 stepping is still the same for the transformed function as it is for the original parent function. So I'm going to say I have no stretches going on in this, and it's just a simple reflection and some shifts. Well, the way we describe this as an equation is we say g of x, that's the transformed function, equals the parent function. Remember, this is with a reflection inside, but that's only one part of it. Remember, there are also shifts going on. So there's the reflection aspect, but we're not done. We also have, instead of x inside the parentheses, it's actually a shift. It's x, and we're going, where are we going here? This is left. We're going left by 2 units. So remember, a shift to the left is x plus 2. And then we're also going down by 2 units, so that's going to be a minus 2 outside the parentheses. So there we have it, f of negative x plus 2 minus 2. And now all that's left is just turning this into an equation, which shouldn't be too bad. If you remember that f of x equals 2 to the x, then what we have here is f of something that's obviously not x, so we're just going to, whoops, that's not what I want. We're going to write it this way. We're going to say 2 to the something that's not x. It's negative x plus 2, that thing in the parentheses, and then minus 2. That is our transformed function equation.